We're starting with one-step multiplication inequalities. 2 days ago we talked about one-step addition inequalities. Yesterday we talked about one-step subtraction inequalities. Today multiplication inequalities. And really it's not too much different from the last 2 days, except for one big thing. Okay. Looking at this inequality, can anyone read that for me? Can anyone just read it just the way it is? Yep. What? Okay, 21 is greater than or equal to 3r. Is the variable by itself? All by itself on one side? No. What's happening to this variable? It's being multiplied by 3. What undoes multiplication by 3? Division by 3. So I'm going to divide both sides by 3. Now I have a little note on dividing that I want to keep track of. I usually use the bar for dividing. The reason I use the bar for dividing is I think I see some of you doing this. Okay, that's okay, but why is this technically not okay?
3 divided by 21 would be different.
Yeah, it's 1/7, but it's really supposed to be 7. So is that a difference? Yeah, by the way, does anyone know what 1/7 and 7 are? 1/7 and 7 are? They are reciprocals. Okay, keep that word reciprocal. That's toward the end. I'm going to erase this here just to start all over. Okay, so I use a little bar underneath the numbers. All right, what's 21 divided by 3? 7. Greater than or equal to r. Go ahead and graph that if you haven't already. Graph it, please. I'll ask a few of you how to do that. And hopefully by the third day of us going through this, you're like, okay, I know what kind of circle it is, and I know which way it goes. And that's good. So Jackson, what kind of circle goes on 7?
Closed.
Brad, why is it closed?
Because it's not equal to, or it has a line under it.
Yeah, because it is equal to, right? It is equal to. Drew, which way does it go? To the left. Why is that?
Because 7 is bigger or equal to r.
So shouldn't it be bigger?
Well, 7 is bigger. R is less than.
There you go. R is less than or equal to 7. Yep. And you're like, wait, how do you know that? Well, can't you rewrite this using the symmetric property as that? R is less than or equal to 7. So you should be able to look at it both ways. So far, so good? Okay, that's not too bad. Just divide both sides by 3. All right, let's move on. Go ahead and solve this one. You do it on your own. Just get good practice with this. Get the graph. Once you solve it, once you get your graph, I want you to get one number that should work and one number that should not work. Do you guys remember looking at your graphs and saying, this number should work, this number should not work? Just pick one of each after you graph it. So just work it out, graph it. Give me a number on each end. Okay, Jack, how do I get x by itself?
Divided by 7.
Divide this side and this side by 7. I get x is less than 9. Darius, what kind of circle goes on 9? Open. Why is it open? Hudson.
Because there's not a line under it.
Yeah, it's not equal to, so it's an open circle. Sophie, which way does the line go?
To the left.
To the left. Matthew, why to the left?
Because x is less than 9.
Good. It's less than, so it's any number to the left. Now, I had a question in the other class that I want to answer before you ask. Do you notice how I keep shading in the lefts? Like I shade in from the circle to the arrow? Do you need to do that?
Yes.
Good. Yeah, you do too. I do it every time. Why though? Because what I'm saying is not only is your answer less than 9, which means the arrow keeps going to the left, but it includes every single one of these numbers that are in here. How many numbers are in here? Infinite numbers like 8.5, 8.2, 5, 3, 7, 9. Repeating. They're all in there.
8.1.
Yeah, 8 point. Yes, sorry. Did I say 9? Blame it on the... Thank you. Okay. So yeah, all those numbers right there fit, and so we need to shade in that little line. Any questions so far? Pretty straightforward? Okay, here's the big difference. Should have a negative there. All right, write that problem down. It's not the decimal. Is it the negative? I don't know. Okay, let's work this out. Oh, you know what? I forgot on this one, and I need to make sure I get this. It's negative 4.8t. Yep. Trying to make it taller than... don't work that out yet. Let's go back here. Do you guys remember I told you pick a number that works and a number that doesn't work? So, Henry, pick a number that works.
6.
Okay, a number that works is 6, which is over here somewhere. All right, what's 7 times 6? 42 is less than 63? Yes. Pick a number, Hagen, that does not work.
11.
11's out here. It doesn't work. Let's see. 7 times 11? 77 is less than 63? No. That's why we didn't shade it. Please remember that. Oh, there you go. All right, now let's look back at this one. What's happening to t? It's being multiplied by negative 4.8. What undoes that? Division, negative 4.8 on both sides. So then here, these cancel out. I get t, and then what's a negative, by the way, divided by a negative? Okay, so I know my answer is going to be positive, but I'm going to do 144 divided by 4.8. So yeah, a little bit extra step because that's doing division of decimals. Get my decimal point where it belongs. 48 doesn't go into 14. Does it go into 144?
Yes.
How many times?
3.
Okay, it goes into it 3 times exactly. So what's my answer? 30, right? It's 30 right here. So t is something to positive 30. Graph it. Notice there's a big gap there, and it's on purpose.
Wait a second.
Ah, swivel. You know what happens? He gets mad every time I turn around, and so he starts looking at you guys. All right. Anyway, he saw you working, by the way. I don't know who he picked up, but he saw you working. I hope. Go ahead and graph that here. I start with 30. I'm going to keep it right here. And then 31, and then 29. What kind of circle goes on 30? Close. That sounds good. Line going to the...
Right.
Okay, is that what you guys get? Check it. You may begin. Would you guys pick like 31? See if that works. Should 31 work? Yeah. Okay, so here I'll put negative 4.8 times 31. 8, 4, 0, 24, 14, 8, 8, 4, 1 point. That's negative, right? It's negative. Negative 148.8 is greater than or equal to negative 144?
No.
That's not true. Oops. Wait, did we do the division right? I'm going to go back here. Yes, we did. What happened? This is what happened. When you divided both sides by a negative number, the direction of the inequality automatically switched. Automatically. You're like, how does that work out? Well, first of all, let's see if that actually even works at all. So, according to this right here, shouldn't it be a line going to the left? Okay, pick a number that should work according to this graph. Sorry, say that again, somebody?
29.
Okay, 29. Let's just go with 29. That's fine. And you can pick any other numbers. All right. Negative 4.8 times 29. That should work, right? 72, 36, 43, 0, 16, 9. What is that? 0. Okay, 2, 9, 13. Decimal point. Negative. Is negative 139.2 greater than or equal to negative 144?
Yes.
Yes. That's how much it is. All right. this works. What happened? Here's what happened. If I gave you this inequality here, what kind of circle goes on -2? Closed circle line going to the right. Okay. But if I gave you this, how would you get t by itself? Is t all by itself?
No.
Technically, is it by itself? I'll get your question, Drew. Is it technically by itself? No. What's there? A -1. How do you get rid of that -1? Divide both sides by -1. What's -1 over -1? Positive t, or positive 1. And then what's here? 2. What happens to the sign? Switches. You're like, no, that can't be true. Let's graph it. Closed circle on -2, line going to the left. What number should work? 1. Let's see. Ready? The original problem. What's -1 times 1? -1, right? -1 times, remember, 1 is -1. Is -1 greater than or equal to -2? Yes, this checks. That's why I had to switch. Anytime, listen to me very carefully, anytime you multiply or divide both sides of an inequality by a negative, what happens to that sign? Switches direction automatically. And it checks.
Even if it was dividing and then you had to multiply those sides?
By a negative,
by
yes.
A negative.
Mm-hmm.
Why does it switch?
Because what it's saying is, like in this problem, remember how I could read it? I'll rewrite it. -t greater than or equal to -2. It's technically saying the opposite of t is greater than or equal to -2. So t is less than or equal to +2. So the signs switch, but so does that inequality, and it always works that way. So this is what I want you to do. And that might not be the best explanation, but when you're talking about the opposite of a number, you're switching the inequality around. So I know that's confusing, but it's true. Does it work though? All right, let's check it out. Let's look at this one right here. Let's see if it works. I don't know. How do I get x by itself? Divide both sides by -3. Okay, so what's 30 divided by -3? -10. What's -3x divided by -3? Just x. Did I divide both sides by a negative?
Yes.
So what must happen to the inequality?
And that's which sides.
It must switch directions. It must. Has to. Because you were talking about the opposite of x. Now you're talking about what x is, so it had to switch directions. I'll start my graph. Excuse me. What kind of circle goes on -10? And in this case, where does that line go? Excuse me. Be careful. Some of you like these problems so much, I can give you more. I don't mind.
Right.
Why right?
Because it's greater than.
Okay, do you guys see that this says -10 is less than or equal to x? Do you remember the symmetric property? X is greater than or equal to -10. So that means the line goes to the right. And here's what I'm going to say. I feel for you right now because right now you're thinking this. Mr. A, the problem started with a greater than symbol. I think it's that for you guys, right? Greater than symbol. Greater than or equal to. And then you had to do this. And then you had to do that. Isn't that what you did? You went back and forth and back and forth. Why did you go back and forth? Well, the first reason you went the other direction is because you divided by a negative, right? So we switched it. But then why are you saying it's greater than, Mr. A? Well, how do you rewrite this using the symmetric property? So are we using a couple things at once? Yes. Do we have to be careful?
Yes.
Thank you. Yes, you do. You have to be careful. But, Mr. A, I hate this because you're doing this and this and this and that. Okay, even if you totally like you did not get that, you're like, I don't know why you did that, and I don't know why you did it again. What number should work here? Give me a number that should work. Go. Negative 8, which is right here, correct? Shouldn't that work according to my graph? Ready? Is 30 greater than or equal to negative 3 times negative 8? Well, what's negative 3 times negative 8? 24. Positive, right? Negative times negative. 24. Is 30 greater than or equal to 24?
Yes.
Give me a number that shouldn't work. Does not work.
11.
Negative 11. Negative 11 should not work. What's negative 3 times negative 11? Positive 33. Is 30 greater than or equal to positive 33? Anybody? Is someone there? Is 30 greater than or equal to positive 33?
Yes. No.
No, that's not part of my solution. Okay, can you check these answers?
Yes.
Yeah. If you accidentally did this, you filled in this arrow going to the left, you're like, man, I hope that's right. Can you check it? Yeah, you can know if you're right or wrong just by putting it up there. Okay. Let's get more practice here because, yeah, this is not very nice or easy. Oh, my goodness. Write that down. Let's just write it down. Sorry, I forgot to say it gets harder.
7 plus 17 and minus 7 minus 3.
Okay. Do you remember on these problems, we have to make sure that both sides are as simple as can be? Is the left side very simple?
No.
How many terms are on that left side? 1, 2, 3, 4, right? We have 4 terms. Are there any like terms?
Yes.
7 and negative 7, and 17n and negative 3n. Okay, can we combine those two pairs? Yeah, what's 7 plus negative 7?
0.
Yeah, they cancel each other out. They're just 0. And what's 17n plus negative 3n? 14n is greater than negative 28. Can you do that one? Yes, you can. Quiet crowd today. I'm having to work for every joke that I give here. All right. I want you to graph it, and I want you to check it, and I want you to be careful with the direction of your sign. Remember that? That's the whole point. Whole point of that. Okay, go ahead and do that. What a great question. What do you divide both sides by? Okay, so you get n, and then here you got negative 2. I'm going to leave that symbol alone because I'm going to let you figure that out. I know it's going to look something like this. What kind of circle goes on negative 2? Open. And your job is to tell me which way it goes. Mr. A, I don't know what to do. Pick a side. But then how do I know it's right? Check it. But Mr. A, it's wrong. Switch it. Yeah. But I want to get it right the first time. So do I. So we're in the same boat. Which way does it go? Let me do that again because I heard both, right? Which way does it go?
Right.
Right? You mean to say the same? Why? I did not divide both sides by a negative. Is that a negative? No. So I didn't divide both sides. Do you guys remember how I keep saying, do this to both sides, do this to both sides, both sides, both sides, both sides? You know why I did that? Because I'm prepping you up for this problem. Did you divide both sides by negative? No. So there's no reason to switch that direction, and it is a greater than. But does that check? Give me a number.
0.
Yeah, negative 1, 0 would work. Okay, ready? Negative 1. Okay, 7 plus, what's 17 times negative 1? Oh, sorry, 7 plus negative 17. Minus 7. What's negative 3 times negative 1? Positive 3. Oh, I really hope this works. What's 7 plus negative 17? Negative 10. What's negative 10 minus 7? Negative 17. What's negative 17 plus 3? Negative 14. Is negative 14 greater than negative 28? Yes, this works. This is correct. Was that a hard process to check? I think so. It's not easy, but it's possible.
Can we just times 14n by negative 1?
Yeah, you could have checked it right here. But this is what the issue with that is. Yes, it works in that one, but that's because we did it right. If you accidentally combine these two the wrong way and you got that, then oh yeah, it works, but it actually didn't work. So that's why I put it in the original problem. That's actually a good point. You know what we're doing in Algebra 1? We're not doing this, but are we checking our solutions? Yes. And I'm telling you, put them in the original problem because that tells you if you're right or wrong. Okay, any questions? Or forever hold your peace. Are you sure? No more questions? Because it's coming. No. So, just write it down. How about that? Write it down. I'm building up the intensity here, but you realize it's not that bad.
So are we going to do fractions?
Excuse me?
He said, excuse me, that means yes. So.
Can we just focus on this problem? Okay, do I have any like terms on the left side? Yes. What do I do with 2.6d and negative 4.6d? You add them and you get? Negative 2d is greater than negative 6. Mary, what do I do to both sides?
Divide it by.
Divide both sides by negative 2. Remember, both sides. What do I get here on the left? D. What do I get on the right? 3. What do I get in the middle?
Less than. Less than.
Why less than, Brad?
Oh, me? Because when you divide both sides by negative.
Yes. What happens to the sign? Switches. And Andrew, what kind of circle goes on 3? Open. Henry, which way should it go? To the left. Now, people say, Mr. A, does it actually work? Yeah, it does. You pick a 2, put it in here, put it in there, and it does work. Okay, so you can check them. Drew, what was your question?
No.
Here's your answer.
Hey!
That wasn't dramatic enough.
Why are we happy to have homework?
Yeah, I've never seen a class so happy to have the homework screen. That's cool with me. Goodbye, Swivel.